very much thankful to our one of the resource person of the session one, Professor Falguni Gupta sir, who already gave a nice presentation on data management. Now I am requesting my our director sir for say something about the session on this data management. Director sir, please.
Good afternoon, everybody. No problem. The experts are there. They will speak on the data management. My request is also, Sir Vidyarthi will join soon. And till he is not joining, my request is all the participants should ask the question. If you will not ask the question, the doubts which are in yourself will be clear. Sometimes what happened that we don't ask the question in hesitation, that what the people will think, what I am going to speak, doesn't matter. You start speaking, and when you will speak, you will clear your doubts. And the process of the doubts, yours is going to be cleared by the experts. Other people will also be benefited. So, all the participants are requested, please ask the questions. And don't think that any question is not relevant or this question is very relevant. All the questions are very relevant. They have their own importance. And we know that the letter A is also very important. If you don't know the A, you will not be able to write a big vowel and not be able to write anything. We have called very good speakers, very learned speakers. May be possible that you are knowing all of them, or it may be possible that you are not knowing. This doesn't matter. Our next speaker is Professor D.P. Vidyarthi. He is a professor in Jawaharlal Nehru University, New Delhi, and he is going to present his talk after a few minutes. Even in the third session also, Sir Munesh Chandra Trivedi is going to present his talk, and he is in NIT. Then tomorrow also, the D.K. Logyal, who was the dean in Jawaharlal Nehru University, he was the head department of Jawaharlal Nehru University. He is also going to present your paper. And in the process of online, you are going to have the personal contact with the speaker. It was very good that we all have gathered at one place and the learned speakers have been called in our Institute of Modern Technology. And in the front of you people, he had presented his talk. That was good. But doesn't matter. The situation has changed and we are passing through the pandemic time. And this pandemic time has changed the whole world in a different way. So we are having the application program in the online mode. So even in the online mode, Mr. Ramesh Gupta, please off your video. Even in the online mode, you are able to see the face of the speaker, and when you are speaking, you may on your video. There will be only two videos, one the person who is speaking, and one the person who is asked the question. I don't think by opening the video of two persons, there will be any network problem or there will be a congestion and something like that. So please ask the question again and again. And we all know that this data management is going to play a very important role. Suppose I am taking one example, and that example is we are listening that driverless car is how the car will operate. The operation of car will depend totally on the basis of data which the car intelligence system will have. If the car intelligence system will not be able to take the data quickly, then it will not be able to drive the car safely. Suppose our car is, we are driving the car and the driverless car is moving with a speed of 100 kilometers per hour on a highway. Suddenly some obstacles comes in the front of that and the distance of that obstacle is not more than 100 meters. So the car camera captures the pictures of that object and do the processing and then calculates the how much pressure we have to put on the brake of the car so that this car should not collide with that object. Now you see, you are taking the data, that is the image of that object. You are storing that data, not only the image of that data which has come in the front of you, but you have to take care of all the objects which are in the back of your car. That is possible or it is not possible. There will be a lot of cars which are coming with the same speed or more than your speed or less than that speed and there will not be one car. If the highway is of the 3 lane or 4 lanes, so there will be one vehicle in all the 4 lanes. So if you are taking side of your car in right side, then there's a chances the vehicle which is coming from your back from in that lane may collide. And when not that vehicle is colliding with your vehicle, a lot of vehicle will collide with that vehicle one by one, and so on. The similar situation will happen if you turn your car left side. If you are not turning your car right side as well as you are not turning your car left side, you are moving in the same lane and trying to jam the wheels so that you should not collide with the object which has come in the front of you. Even though there chances are that the things that the vehicles which are coming from your back may collide. So you have to take the decisions. There's a lot of data is there, a lot of images are there, and you have to take the decision on the basis of that what to do, how much pressure you are going to put so that you should not collide with the object. The vehicles which are coming from the back, they should not also collide with you. This is one example. I am taking the second example in which it is a two-way communication. That is, it is a two-way traffic. That is, you are moving in this direction and from your opposite. That is, in the front of you, the vehicles are coming. And the vehicles are not incoming. There are various types of vehicles. The trucks is coming, the bus is coming, the jeep, car, cycle, motorcycle is coming from that side. Even the people who are moving on their foot, they are also coming. The same way in the side from which you are moving, the same type of vehicles and persons are there. That is the trucks, cars, jeep, motorcycle, cycle, and the person who are moving on their foot, they are also there. So in this scenario, in this circumstances, you have a lot of data. You have the data from the front side, you have the data from the back side, and then on the basis of that much data and one stationary object has come 100 meters away from your vehicle is also there. So if you are moving from this way or that way, chances are there that you are going to collide from the front as well as you are going to collide from the back also. So that is so all these decisions, the AI will artificial intelligence, whatever deep learning or whatever terminology you want to say, you are free to say. Tomorrow, today we are saying we are the all the problems is going to be solved by the deep learning. Tomorrow may be possible that instance learning or human learning or a new type of methodology, a new type of thinking, a new type of scenario may have emerged. But all these things will take the decision on the basis of what the data is provided to you. They joined. I think Professor is still not joined. So, so that's the thing. So data is very important. And we are saying that you started from the flat files, then the various type of databases. We moved from that one to hierarchical database, and there was a team, Codocial team, who has developed the network databases, and some advantages were there in the network databases, some advantages were there in the hierarchical databases in comparison to that system. But then we come to the relational database. The credit goes to E.F. Korsov. He was a very gentle man. He was a very intelligent person. He has converted the whole thing in the mathematics and with the help of relational algebra and relational calculus. He developed a very nice and intelligent query language, and we all are very fond of databases. The work is going on, but this is the strongest point, or you can say this is the weakest point of the human mind. Whatever you want to think, you are free to think. Say it is a weakness, okay, fine, it is a weakness. If you say this is the strength, you are right. It is a strength. When the things are utilized in a positive direction, it is a strength. When the things are utilized in the negative direction, it is the weakness. But I'm not going to put myself in that that problem that it is a strength or it is a weakness. Same thing only that relational database. The human being doesn't stop there. Further advancement has taken place, and we have the object-oriented data model, databases, data models. We need to stop there. Then we have the data mining and etc. And for the data mining, we have the data warehousing. We need to stop there also. And then we have the cloud computing and so on, so on. And we are not stopping there also. And then we are talking of the edge computing. So we have started from the flat file system. We have moved to the cloud, and now we are moving to the edge computing, and maybe move further. But what we are doing in all these things, we are doing only one thing, that is we are managing data. Why these type of changes are? Because the types of data is more and more. Previously, there was only one file. After that, the image has come. After that, the sound has come, and so on, so on. A variety of data has come. And the variety of data is going to be started coming. You have to store them in a different way. Why? Not only one that variety of data is coming, the volume of data is also going to be. You realize what tremendous type of data every day is coming to your mobile. A normal person has more than 100 WhatsApp chats. If he is involved in 2, 10, 5, 30, 50 groups, then personal chatting. Then he is seeing the images, he is seeing the emails, he sees chat, he sees some information on the Googles. And he sometimes he talks through his mobiles. He receives the calls on his mobiles. He receives the messages on his mobile. He sends the data, he sends the messages from his mobile. So a lot of data, incoming data as outgoing data is stored on your device. Your simple mobile processes that much of data. So when we are working in a huge organization, or when we talk about a country nowadays, when we are talking about the world as one family, you can imagine how much data we have. Take social sites like Facebook, WhatsApp, and so on. There are various types of other things. Today, just now, few hours back, I was listening the message of this it's Dr. Santji. So he was saying that the India is developed a chat which is just like what the WhatsApp is. Ravi Shankarji Maharaj, he was saying that one young people of our country has developed a social media sites like WhatsApp. And he was saying that all the facilities which is available in the WhatsApp is also that social media chat group. So if we have Indians already coming with this social type of chat, China has already, then our United States of America is already, Google has doing a lot of things. Even I am sitting here and you can see my location. I have opened my location, my current location point in my mobile. My mobile will say that where my mobile is. So what my message again and again is we have to not in the ocean. A, a tremendous of ocean. Yesterday I was reading a article, and in that article it was said the small points which you are seeing, they are the galaxies. They gone inside that small points. It was saying that it has a millions and millions of stars, and one star may have more than what our sun star has the family. That is only one star has got the sun, Earth, Venus, Mars, Jupiter, Saturn, Plato, etc., etc. And each one has got its sub-satellites like Earth has got the moon, etc., etc. So how much tremendous data we are having, and that we have to process. I am stopping myself because Vidyarthi Ji has joined, and I am very grateful to him that he has accepted my request immediately. And whatever the time and date I have assigned, he has said, okay, fine, sir, I'll proceed. And it's a very important thing. He didn't join at 12:10. He has informed us that he will join at 12:30, and he has joined. So I am not going to be between you and Sir Vidyarthi Sarji. He will deliver his talk. So nice of you. Thank you very much, sir. It is very nice.
Namaskar.
Namaskar, namaskar. I pray to the Lord that
Thank you. Thank you
and we
for
keep our praying.
Thank you for being so kind to me.
Sir.
Sir, on behalf of students, faculty member and management of RRIMT, I welcome Professor D.P. Vidyarthi sir for joining us for the second session 2 of Faculty Development Group Data Management. Over to Dipti ma'am.
Thank you, sir. I am Deepthi Ranjan on the behalf of IIMT Lucknow. Welcome you all in the second session of ATTV sponsored MPP on data management. I have been privileged to elect Deepthi Vidyarthi sir. Presently, he is working in the School of Computer and System Science, Jawaharlal Nehru University, Delhi. Sorry. His expertise area are parallel and distributed system, grid and cloud computing, mobile computing, and Internet of Things. Sir has published more than 100 papers in various international journals and transaction in IEEE, Elsevier, Springer, Pele, World Scientific, and many more. He is the author of 3 books, and sir is also member of IEEE ISRT and IACSIT and IAENG. Once again, I welcome you, sir, and feel very privileged to introduce you. Over to you, sir.
Good morning, all of you. I still hope that winter and chilly good morning, all of you must be experiencing cold. Being in North India, we are feeling so. Delhi is today very cold without any sunlight, so it's damn cold. But mostly located, situated in your house must be feeling comfortable. Uh, Thanks for the kind introduction. Thank you, Professor Tripathi, my Guruji, my mentor, in one way or other. Thank you, Dr. Thakur. Thank you, Dr. Deepthi, for introducing me. Straight, I am coming to the talk that I have to deliver, and maybe I'll be switching over to the presentation mode. In the meantime, I would request the organizers that if you have some problem regarding my voice, mostly voice, if it is not coming up, sometimes it between it delinks, then you can call me on mobile phone because
Sure.
otherwise
Sure,
you
sir.
usually do not notice.
Sure, sir.
Okay, so that's my humble request to the organizer.
No problem, sir.
Let me share the screen. Is it visible now?
Yes, sir.
Hello.
Yes, sir.
Uh-huh.
Will, sir.
Okay. So,
Full screen, sir, please.
yeah. The title of my discussion today will be how we do apply the auction mechanism. Most of us are familiar with the auction. I mean, in general, we are familiar with the auction, where sometimes the variables are auctioned by the making a kind of a bid. And cloud computing has also grown in a way that houses the number of resources, the computing resources, as well as the storage. So how these cloud resources are to be provisioned using the auction mechanism. This is the work that we have done. Our research group here are working on this particular problem. So I thought of speaking on the this particular problem today, so that you are also aware of how the auction can be applied not only for the cloud resources, but for any such resources which are shared pool of resources, which are to be shared, which are public resources, being used as the public resources, and which are to be shared among the number of users. So I will be talking about the specific resource of the cloud computing, I mean the cloud resources, but I'm pretty hopeful that you will be able to apply the auction mechanism even for other resources as well of your discipline, I mean in the discipline that you are working. So let us move forward. Total outline of this particular talk will be concentrating upon that I'll be introducing you some basic cloud, introductory cloud, that is what is cloud computing, what are the different models of the cloud computing, along with some related emerging paradigms that have come up in recent with the emergence of the cloud computing and many applications that are being executed on cloud. Then I will introduce you the basic concepts of auction, that is what is auction, what are the basic terminologies that are used in auction in general. And then thereafter I will be giving you how auction has been used for the resource provisioning in cloud computing. And finally, I expect you that you will be motivated to apply the auction as a tool in your research area, in the research area that you are working. So this will be my total aim while delivering this particular talk. Now coming to the part one, that is the cloud computing, and introducing you the concept of the cloud computing for the knowledge of those that are not very much aware of the cloud computing and the related paradigm. But I'm pretty hopeful that many of you are aware of the cloud computing, because since last 10 years it has emerged as a discipline in computer science and engineering. Besides, many of the organizations are now switching over to the cloud resources. So pretty hopeful that you are aware of the cloud computing term, but still I'm introducing you.
Sir, full
So as per the definition of the NIST, that is the National Standard of Science and Technology, which is a US-based organization, for setting the standard of so many definitions and paradigms, defines the cloud computing as a model for enabling ubiquitous. Ubiquitous is basically used for the term for anytime, anywhere kind of a computing. Anytime, anywhere type of a computing.
sir, if you don't,
Ubiquitous. Hello.
hello, sir,
Yes, please.
if you don't mind, please full screen. You share your screen, full screen mode. This is
Is it not coming?
coming, sir, but half. You please set full screen. You share.
It is full screen only.
Okay, 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 sir.
Okay.
Okay, sir.
Is it full screen
Yes, sir.
now?
Now full screen here. Thank you, sir. Thank you.
Okay. Okay. Yeah. So, as per the definition of the NIST about the cloud computing, they define the cloud computing as a model for enabling ubiquitous, convenient. We say convenient because it's very easy to use the cloud resources. As many of you are using it also, many even who have nothing to do with computer science, who has nothing to do with engineering at all, they are using the cloud resources. So it is because it is convenient to use. Then on-demand network access to a shared pool of configurable computing resources. So it's on-demand we say because as and when we are using the computing resources, probably one has to pay for it. So we say that you demand whatever you require and then you will be granted the resources. And when we say shared pool of configurable computing resources, it includes the networks, servers, storage, applications, and services. Many kind of services that are offered on the cloud resources, on the cloud computing platform. That can be rapidly provisioned. Rapidly provisioned says mostly it is an automated type of provisioning of the cloud resources and released with minimal management effort. When we say with minimal management effort means in between two human being is involved. So it is totally automated kind of a resource provisioning, which is granted to you and which is released also automatically when and where the resource usage stops. Some of the cloud computing concepts are the virtualization. Virtualization plays a heavy role in the cloud computing because most of the cloud resources are virtualized resources and it is offered in form of the virtual machines. I hope that you are aware of the virtualization concept because in operating system we started using the virtual memory concept long back. So similarly as the memory is virtualized, similarly the computing servers are virtualized, the hard disk is virtualized, the network is virtualized, all the cloud resources are virtualized. So virtualization plays a very important role in cloud computing. Then internet technologies because we can use the cloud resources using the internet. So internet technology is very important and how quickly we can pass on our data through the internet to the cloud resources is important and that is why we say that one of the component of the cloud is internet as well. Then at the back end we have the shared pool of a good number of resources, cloud resources in form of computing that are being offered to the user. So a big grid of the computing resources have been constituted at the back end of the cloud. So grid computing also plays a role in cloud computing and that is why it has been included as one of the components of the cloud. Then comes the utility computing because now the computing is also being treated like the water, like the electricity. The computing is also being treated as a utility. So a utility computing also becomes the part of the cloud computing. And then as I told you, the autonomic computing because the resource provisioning with minimal managerial effort it itself says that the computing should be autonomic. So these are some of the components of the cloud computing which have been defined by the NIST. Introducing you with the concept of the cloud computing, it's usually a pay-as-you-go model. So pay-as-you-go model says that as and when you require the resources, you use it for the time being, and you will be charged for that particular resources only for the time being that you have used. So that is why we say it is a pay-as-you-go model. I mean, whatever you use, whenever you use, and for whatever time you use the cloud resources, you will be charged only for that much amount of the time and that much amount of the resources that you are using. So usually it is a pay-as-you-go model. Some of the essential characteristics of the clouds are on-demand self-service, because self-service we say that no human being is involved between you and the cloud. So it's a on-demand, as in when you require the services, and you do have to use it yourself. So it's on-demand self-service. Broad network access we say because nowadays a huge bulk amount of data is being passed over the internet to the cloud. So you need a broad network access to access the cloud resources. Then resource pooling is also one of the essential characteristics, because at the back end, as I told you, not only one server, one machine has been kept at the cloud data center, rather a big pool of the resources are there. So resources are usually pooled in offering the cloud services. Then we say rapid elasticity. This is a term particularly which is used to express the need or to express the requirement of the cloud services in terms of, as we require the resources, you can stretch the number of resources, you can enlarge the number of resources, and the cloud will be able to serve you these resources. And as and when the resource uses are over, you can release those resources. So the working of granting the resources are like the elastic. So the resources can be stretched and resources can be compressed as well. So it has the property of stretching and compressing. So we call this particular characteristic that has the elasticity. Then we say it is a measured or metered service. So metered service or measured service because one has to pay for the services that they are using. So the services that we use are usually measured, are usually metered. So a kind of a meter, you can just assume that a kind of a meter has been kept to measure for how much amount of the services you have used, or how much time you have used the services, and so on. So these are some of the essential characteristics of the cloud. Some of the service models which are popular in cloud computing are software as a service, platform as a service, and infrastructure as a service. So software as a service means you are using the cloud applications as a service. Many of us, even those who have nothing to do with the engineering and science, they are also using the software as a service of the cloud resources. So software as a service says that you are using the applications that are uploaded at the cloud, and you are using the cloud resources for using that, for executing those applications. Like we use WhatsApp, use Facebook, etc., etc. These are the software as a service of the cloud resources. The cloud computing. Then platform as a service is another level where some of the professionals use the cloud resources as the platform to develop the application. So for developing the applications, you don't have to buy the hardware and software. You don't need to do the coding by buying the hardware and the software. Rather, you can use the hardware and software of the cloud resources. And then a kind of a platform is being provided to use these services, the cloud services, for developing your applications. So this is known as the platform as a service. Then we do have the infrastructure as a service, and infrastructure as a service is basically mostly the hardware infrastructure of the cloud, which one avails, like you are using the server which you do not have, rather you are using it from the cloud. And mostly these kind of services, the infrastructure as a services are provided in terms of the virtual servers, in terms of the virtual machines. So the virtualization of the hardware comes at this particular level of the infrastructure. Then IBM defines some deployment model. Basically, the IBM defined three types of deployment model in terms of the private cloud, public cloud, and the hybrid cloud. But eventually, a fourth category has also been added, in this cloud of the deployment for the deployment model, which is the community cloud. I will come over these definitions little later. Now coming to again explaining you the cloud services that I just explained. So at the top you have the client, you have the users that are using these services of the cloud, and at the bottom you have the physical servers, the back-end machines. Physical, which is virtualized also. So you can say that the virtual and physical servers are there at the back. And in between these three kind of services are available. These three type of cloud services are available. That is the application as a service, the platform as a service, and the infrastructure,
हाथ जोड़ के आया हो ना
which I just explained you. Now, if you look at this particular architecture of the cloud resources, cloud computing, then you will find that how these services have been stacked in this architecture. So at the bottom you have the hardware, which includes the CPU, memory, disk, the bandwidth, that is the network, etc., etc. And not only this, you have the virtualized form of these resources as well. So computation is also virtualized in terms of the virtual machine. The storage is also virtualized in terms of the block. So you have the computation as well as the storage, which is virtualized. And this all together is known as the infrastructure. Right? Some of the service players, the cloud service players, are the Amazon EC2, GoGrid, and FlexiScale, which of course provide the cloud hardware, the data center hardware in terms of the virtual machines, in terms of the blocks, etc. Above that, you have the platform as a service, where the software development platform are being offered so that the user can develop their own applications. Like you have the Java, Python, .NET, and for storage also you have the DB, files, etc., etc. And a large number of service providers are here in the providing the platform as a service, like the Microsoft, Google, and the Amazon. These are some of the top players, some of the major players, but there are more than 1,000 service providers at the platform as a service. Then at the top you have the application as a service, which we are very familiar with. Like many business applications are available, web services are available, multimedia services are available in terms of the application as a service or software as a service. And some of the applications that probably you are aware of, many Google apps that we have as of today, Google Docs, Google, and Google Meet also nowadays, on which probably we are talking today here. These are at the application as a service. The Facebook, you have the WhatsApp, you have the YouTube, etc., etc. So a good number of examples are can be put here at the application as a service or the software as a service. Right? Then similarly you have these are some of the service providers probably which we have listed here. Just skipping this. Coming to some of the deployment models like the private cloud. So when the cloud infrastructure is operated solely for an organization, that is known as the private cloud. Like your institutions can have a cloud, can create a cloud, can create a data center, and the services of this data center will be available only to the employees or the students of your organization, of your institution. Then we call this particular cloud as the private cloud. It can be managed by some in-house staff, or even the third party, let's say, management can also do this particular job of managing your private cloud. Then we do have the public cloud. I'm just skipping the community cloud, coming to the public cloud immediately. And then public cloud is something which is maintained by some organization which provides the cloud services to any number of users, to any users. So it is completely available to the public, but not free services like the Googles. They do provide some of free services too, but they do charge for any of the services. And when big organizations are availing the cloud services, then probably
जनरेटर चलवाओ ये अभी चल तो रहा है लेकिन ये ऑफ हो गया
Why?
लॉस कनेक्शन ऑफ समथिंग इंटरनेट इंटरनेट कनेक्शन ऑन करेंगे वो वाईफाई आ गया अब यहाँ मिलेगा ना ये आप लोग तो कनेक्टेड होंगे ना
That we are not taking from the public cloud, but for this management, for the office-related services, we have availed it from the office of DNIs. So that way we do have the hybrid kind.
इनको वो किए ना तो इनके पास
Now, community cloud is something where you see that a cloud is developed for a particular community. It is not private, it is not public, but for some specific community, the cloud services are developed, the cloud services are maintained, and the services are offered to that particular community only. Like we can have the library services, which can be maintained, which can be developed, which can be maintained for all library purposes across the, let's say, across the nation. Across India, we can have the library services maintaining the library cloud, library kind of a cloud. So it's a kind of a community. It's a kind of a community which has developed. So that particular cloud is known as the community. Right. So now coming to some of the major benefits of the cloud. So you see that major benefits which we can say, which we can include is that we do have the less energy consumption while using the cloud service. Now, if you look at this particular figure, which has been taken from the PIPE research, you will find that over the years, if we have not used the cloud services, then the CHG emission, that is the greenhouse gas emission, has increased, which is being shown by the red graph. This chart. So you see that the greenhouse gas emissions have increased by 2020 a lot. But by using the cloud services, the CNG emissions has decreased slightly.
सेशन
So
ठीक है
the adoption of cloud computing would have led to a 30% reduction in worldwide data center energy expenditure. So we are able to reduce the energy consumption, and this is one of the major benefits of using the cloud. Outsourced by cloud computing enables consumer to become more environment friendly. So that is one of the major reason for adopting the cloud computing is that we are able to reduce the greenhouse gas emission, right? But there are many benefits of the cloud, many more benefits of the cloud computing that you cannot overrule, and these are the cost effectiveness. So cost effectiveness says that you don't have to spend much on the cloud, much on your data centers. You don't have to buy the hardware, you don't have to buy the software. Rather, you avail the cloud services and pay only for those services that you have used for the time. So then this whole model of the cloud becomes the cost. So it is a need basis. Cloud vendors provide computing infrastructure only on need basis. Whatever you require, that I'm giving it. And pay by use, that an organization is built only for the computing resources they use. Usually the computing cost includes the infrastructure cost plus operational cost. But you see that here you don't have to maintain the infrastructure at all. So while using the cloud computing, you do have to pay only for the operational cost. So that way, it is most cost beneficial. The cloud computing is most cost beneficial, and that is why many of the organizations are now switching over to the cloud for their the computing resources requirement. Then scalability and elasticity, because I just explained you sometimes back, this is elasticity is one of the important property of the cloud computing, which says that as and when your resource need grows, the cloud will be able to provide you those resources. So let's say at a time you require just one server, and then tomorrow you feel that you require more server, 2 servers, 4 servers, then probably it will take time also to buy the servers in an organization. Moreover, you have to spend on the servers. You have to, because these are the physical servers, depending on the configuration of the storage, you need to spend money on
सर
that.
इसमें 48
This you can immediately grab from the cloud computing. So let's say today your requirement is one server, tomorrow it grows to two servers, the day after it goes to four servers. Immediately
होने दीजिए, आप अपने मोबाइल पे देखिए चल रहा है,
हाँ
चलने दीजिए।
हमने
लेकिन जब आप मान लीजिए होस्टिंग करेंगे, जो फिर आप बोलेंगे ये चला गया तो फिर ये होगा।
हाँ उस समय नहीं काम करेगा तो मोबाइल से कर देंगे। अड़तालीस है। एक बार ये सम्मान से डाउनलोड कर ले तो हम देखें, हमारे जानने वालों में जितने नहीं उनको हम तुरंत बोल के करा देते हैं, और कईयों ने तो कर दिया है।
cloud resource.
ये जो भी डाउनलोड किया ये क्या चीज़ अटेंडेंस है ना, तो अटेंडेंस और 18
Agility is one of the important benefits of the cloud. The infrastructure can be provisioned quickly when required to, and therefore improve the time to market. Using tools offered up in cloud encourages agility.
एक फीडबैक का भी
And obviously, you see that not only the particular software or one or two software while managing the physical data center, physical for the organization, you have to buy those resources or those hardware software can be updates from the cloud computing, which makes the cloud more agile. Device and location independence is another property. You don't have to worry for the room and maintaining the cooling of the room, etc., etc. You don't have to worry for that. Rather, the devices and location are maintained somewhere in the cloud, and that is why the name cloud has been given. You are unaware of where it is being maintained. Right? Many of the organizers, many of the cloud service providers, they might be managing the cloud resources, may not be in India, maybe some other location, maybe in Singapore, maybe in China, maybe in some other places in of Europe or US, wherever it is being maintained, we don't have to worry about that. So that way it is a device and location. Multi-tenancy says that a single application can be shared among the number of users. So that way, for an application, for one application, many tenants are there that can access those applications. So that adds another adjective to the cloud computing. But there are some challenges. So cloud consumers face security problem because now we are giving everything, and now recently you might have experience also by using the WhatsApp. I claim that we agree with the terms and conditions of the WhatsApp so that the data can be shared to the Facebook. Maybe for they say only that it is for the analysis purpose only. And in providing you the better service, they are sharing the data, but you never know what for they are sharing the data, and that is why there is a security problem. So you are putting your everything on the cloud, you are keeping your everything on the cloud, but then how this data is being used, whether it can be misused also, one is not aware. And that is why the security problem has been always treated as one of the major challenge in the cloud computing. Of course, multi-tenancy model adds the security, more security, because the single application is being used by a number of users. How the other users are, let's say, using that particular applications or affecting that particular application, I would say, may add the security threat in the cloud computing. Some other challenges may be not very drastic, but they are like how to analyze the cost, how to offer the cost to the users, and by managing the resources, which we have treated as one of our research area, while provisioning the resources. This analyzing the cost and offering the cost to the user is also a challenge, right? Like the cost, it includes the computation cost, communication cost, integration cost. Computation class where you avail the computing capability of the cloud. Communication class where you avail the communication requirement while accessing the cloud. And integration means more than one service providers are there, more than one servers are there. They may not have the similar nature, they may be heterogeneous in nature. So integration of those servers, integration of those service providers may add some integration costs. Of course, one can introduce the penalty also, because if you do not get those required services, if you do not get the services that has promised to you, then probably some penalty also may be imposed on let's say the service providers, which can eventually be transferred to the user, which can be transferred to the consumer. Right? Even in drafting the service level agreement is also a challenge. Drafting the service level agreement is not an easy job. So service level agreement is something where once a user goes to the cloud service provider, they sign some agreement in between. So it's a kind of a service level agreement where the service providers agrees to the terms and conditions which is being led in the SLA, which is being led in the service level agreement. And maybe if the these service providers are not able to offer you the services as promised, then you can challenge the service providers as well. So to design the service level agreement, it has been experienced that it is also a challenge. So SLA, making the SLA has been treated as a challenge. Scalability, interoperability, and standardization, as I told you. Scalability means, you see that we just said that the cloud can be scaled up and will be scaled down as well. But it may add the challenge also to the cloud service providers, because it has to maintain, it has to provide the services. It has promised the services which is to be provided. So how to while using the resources tactfully, how to offer the resources so that the user does not face any problem. It is a challenge for the resource provider. It is a challenge for the management of the resource, for the manager of the resource. And then, as I told you, interoperability, because lot many heterogeneous devices, lot many softwares are there. Hello,
Yes, sir.
are you able to receive what I am telling you, what I am speaking on? Okay. Oh, yeah. So interoperability has been treated as another challenge. Then of course making a standardization so that all the users face the same. Now the interface to the cloud is same for all the users. So that way it has to make the standardization. It has to develop some standardization which has been treated as a challenge. Now this is one resource provisioning. We treated it as one of the challenge, and we started working on the resource provisioning problem of the cloud computing. So let us understand what is the resource provisioning. Resource provisioning is something which develops some kind of a management algorithm so that the computing resources, so that the storage, so that the memory, etc. are being managed in a proper way. So resource provisioning actually is to supply a set of computing resources for processing and storing data. Right? This is a method which develops, as I told you, which develops the algorithm so that the computing resources can be provided to the user, can be provided to the cloud customer. The method that you develop, that one develops, has to satisfy some constraints like time limit. So you have to provide the resources within a particular time limit, and which is able to meet the time.
चल रहा ना सर?
हाँ फोन तो वही तो हम लोग हो जाने में बाहर कर
Budget also, in a reasonable budget also. So that adds a constraint. Hello.
Yes.
So yeah, if you have some questions, then probably you can raise.
No.
Hello.
Yes, sir. No problem at all, sir. You Please continue.
Okay, okay.
If you have any questions,
Yeah, please.
all participants are requested to share in chat box only. After this
Okay,
discussion
okay.
session, sir, we will
Yeah,
open
sure.
this feedback session, sir.
Yeah, sure. Yeah,
Yes, sir. Thank
sure.
you, sir.
Okay, so let me continue then. Yeah, as I told you, resource budget is another constraint. Maximizing the quality of services while offering the services, probably as there are more than thousands of service providers now, so user is expecting some service quality also from the service provider. So maximizing the quality of services, and when we say quality, there are many metrics, there are many parameters that are used in offering, in providing the quality of service. So maximizing the quality of services is another constraint while developing the resource provisioning agreement. And of course, it has to look into the SLA is not violated. The service level agreement, which has been signed between the user and the service provider, is not violated. Right? It has also to look into that the demand may increase unpredictably. As I told you, sometimes the user may require thousands of computing resources, sometimes it may require 2, 3 computing resources. 2, 3 virtual machines may suffice sometimes. Sometimes it may require maybe 100 virtual machines. So unpredictable demand may grow. So resource provisioner has to look into that how this particular demand can be met out, right? And of course, you cannot rule out this hardware and software failure also. So there is a possibility of the hardware and software failure as well, which has to be taken into account while provisioning the cloud resources. And then conflicts in SLA may create a problem. So SLA, which has been signed between the user and the service provider, and if the service provider is not able to meet those particular promises, we are not able to satisfy the agreed upon services, then of course it has to take some action. Two provisioning plan for computing resources which are popular is the reservation plan and on-demand plan. Reservation plan says that you reserve the resources for a longer period of time. You may not use all the resources, but you have reserved the resources for your users. Right? Like you can reserve the resource, let's say 100 virtual machines to be used for your organization. But maybe sometimes you are using 2, sometimes you are using 3, sometimes you are using 50 also. So this is one plan which we call as the reservation. Another plan is the on-demand plan, which says that you request for those resources only which you require at any time. So, like if you require 3 virtual machines, you request it, you get it. You require 50, you request it, and you get it. Right? Both has its pros and cons. Probably you will come to know very soon that what is the pros and what is the cons of these two planning. Now coming to some of the related paradigms which requires the cloud, computing nowadays in a big way, is one of the data, where one of the paradigm is the Internet of Things. And Internet of Things now produces a huge amount of data. Probably this particular workshop or this particular program is on the data management only. So the data is being generated, a huge volume of data is being generated. Apart from many other paradigms, many other disciplines that are there, IoT in the days to come, IoT will be placed in a big way in this whole cyber space, and which will generate a huge amount of data, which will generate the bulk of the data to be processed by the cloud resources. And the data comes here. One of the important sources of the data is the Internet of Things. So let us see what Internet of Things is. What is an IoT? So this particular term was coined by Kevin Austin at the MIT, and sometimes it has been estimated to be born between 2008 and 2009 by the Cisco. So what is an IoT? If you look at this particular picture also, the picture which it is drawn here, you see that many of the things are on the internet. So far we just assume or we just think that only the computing materials are on the internet. Or sometimes our smartphones are also on the internet. But you see that if you look at this particular picture, you find even our frying pan is on the internet, bulb is on the internet, your refrigerator is on the internet, aeroplane, your car is on the internet. In the days to come, cars will heavily be on the internet. So you see that many of the devices, and rather IoT, the term IoT says that not meaning all the devices, all the physical objects will be on the internet, right? In the days to come. And you will have a big cyber space. with cyberspace where most of the devices, most of the physical objects, they will be on the internet. So, as far as the definition of the IoT is concerned, IoT is the network of the physical objects, which includes the devices, vehicles, buildings, and other items embedded with electronics, software embedded with electronics, because unless the devices are embedded with the electronics, it cannot be on the internet. So, it requires the chip. Software is also required. So, embedded with the electronics, software, sensors. Sensors plays a very important role in the IoT, right? So sensors means there are devices which can sense, and there are multiple type of sensor available as of date, which are become very cheaper also. So you see that a lot of sensors are to be deployed in the area, in the maybe remote areas also as well, with the rich area, forest area, where a huge number of animals are only here and there. Sensors are to be deployed. So sensors play a very important role in IoT. And of course, the network connectivity. They require the network connectivity that enables the object to collect and exchange data. So unless you have the network connectivity with the sensor and the cloud, you will not be able to collect the data, you will not be able to exchange the data. So it requires the network connectivity as well. Right? It has been defined as IoT, Internet technology connecting devices, machines, and tools to the Internet by means of wireless. This is another form of a definition which you can understand. Connecting devices. A lot more devices are to be connected through the Internet, to the Internet. Machines and tools to the Internet by means of wireless technologies. Of course, the whole, this IoT has to be the wireless. Over 9 billion things connected to the internet as of now, which is likely to grow to 20 billion, which is likely to cross 20 billion in the near future. We have reached almost 20 billion as of date by the news which came very recently in IEEE Spectrum magazine, which says that we are now able to reach around 20 billion devices, 20 billion physical devices that are connected to the internet. Of course, IoT is the unification of many technologies. As I told you, it is low power embedded systems, the cloud computing. So VSI and many related electronics integration technology also plays a important role, like the microelectronics, the nanoelectronics technologies, which of course does, which of course develops the kind of sensors, smaller sensors, low energy sensors, kind of devices that they have developed. So this low power embedded system plays a very important role. So it's a unification of the technologies such as low power embedded systems, the cloud computing, as I told you, because at the back end you have the cloud computing only, the processing system, the big data, the technology which is used to process the data, because a huge amount of data is being used. So the separate discipline has been developed. Probably many of you are aware of the big data technologies. So big data, which often use the machine learning technologies, and many machine learning technologies are being used nowadays for processing these data. And of course, the networking is important here in the IoT. So these are some of the technologies which all together make the success, leading the IoT technologies. I mean, in the development of the IoT technologies, these are some of the technologies probably which plays very important role. And protecting definition is the IoT is the network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. So this is the definition which has been given by the Gartner research. This is another definition of the IoT. Now, another related discipline is the fog computing. So, cloud computing, after the cloud computing related discipline, fog computing also came in a big way, which is being defined as a horizontal system level architecture that distributes computing, storage, control, and networking functions. So, almost everything is there in the cloud: computing, storage, control, and networking functions. Now, it comes closer to the users along the cloud to think about it. It comes closer to the user. So as the name cloud and fog, has been derived from the nature, fog is relatively closer to the user. Cloud is little farther to the user. So that way, if you require the devices, if you require the computing storage, sometimes networking, etc., which closer to the data generation point, closer to the user, which requires the processing. Then these services can be made available near to the devices, near to the user. This in itself forms a discipline known as the forms a paradigm known as the fog. So this is another form of the cloud computing, but nearer to the user, but nearer to the devices.
सर फाइल बनाइए उसमें सीट बना
It is an extension of the traditional cloud-based computing model, where implementations of the architectures can reside in multiple layers of the network. So as I told you, it's an extension of traditional cloud-based. So whatever is there in the cloud, you can just assume that these are there in the fog computing. You can just assume this as the cache memory as the and the main memory. So you require the main memory, but for faster access, for faster processing, you require the cache memory. Similarly, for time-prone applications, for time-sensitive applications, you may not wait for the cloud to process the data, because it is not only the cloud has to process the data, rather the data has to go all along through the internet. So the data has to traverse from one place to another, and if it is a big data, probably it will take huge amount of time. So maybe the computing takes lesser time, rather the movement of the migration of the data from one place to another, and then coming back to the data generation point, or the coming back to the devices which has generated the data, may take a huge amount of time. So rather than sending the data over to the internet to the cloud, rather we can process the data nearer to the devices that are available, nearer to the devices, to the data generation points that are available. So that way, the discipline for computing has come up. The discipline of the fog computing has been developed. And similar is the edge computing. Sometimes many of the literature says that the fog and edge is same, but there is a difference between the fog and edge computing. Edge computing is something if your device can process the data. Many of the devices are equipped with the processing techniques, like your smartphone. So if the smartphone is now equipped with the powerful processor, so if that particular smartphone can process the data, then why to send it to the fog and the cloud? Rather, the data can be processed at the edge itself. So this particular computing, where the device, where the data is being processed at the edge itself, is called as the edge computing. But of course, this fog and edge, they are almost treated similarly. Because many times we can form the big network of the mobile devices also, that can form a big network and they can assist each other in data processing. So that way, the term edge computing is defined. Some of the benefits of the edge computing may be the latency, maybe the privacy. Latency because the data will not be sent all over the internet to the other place, where to the cloud where the data is being processed. So latency will be reduced. So latency is one of the benefits. Privacy and security is another thing, because your data will not traverse. So there is least possibility that the data is being breached in between. Some phishing and some many other, the security threat that appears while processing and sending the data to the cloud will disappear. So privacy and security is another benefit. Then of course you are saving the bandwidth as well. So these are some of the benefits. Now if you look at this particular picture, I hope you will be able to differentiate between the cloud, fog and the edge devices. So you see that the cloud are thousands but powerful. So some data centers in thousands, but they are powerful. They have huge processing capacity, huge data store. Fog devices are millions, but they are more in numbers, but they are not as powerful as the cloud devices. And mostly these are the base stations processors, the base station servers, the routers, the bridges that are being used in between while sending the data to the cloud, in between that are used, which are nearer to the edge devices, which are nearer to the data generation points, are known as the fog. The fog. And then of course you have the edge devices. These are actually the data generation points. Your smartphone is generating the data, smartwatch is generating the data. Maybe Raspberry Pi kit is generating the data. Then your table lamp is generating, and so on. These are billions in number. As you see that the edge devices are billions in number, but they have least processing capacity, and that is why they require the cloud and the fog devices for data processing. If you look into with the another point of view, this particular figure again it says the same. This is the IoT layer. are the edge devices which are generating the data. Above that is the fog layer, and then above that you have the cloud servers, where ultimately, if these are not able to process the data, obviously the cloud has the powerful capacity of processing the data. So then this is the picture which you can look into and can relate the IoT, fog, and the cloud. So these three are the disciplines probably which has emerged in recent in a huge way, in a big way. Now, up to this, it is okay, it is going well. Just hello.
Yes, sir. Everything is fine, sir. You are audible. Please continue, sir.
Okay. So I'll continue
Yes,
then
sir.
thereafter. So now coming to the this economics part, coming to the cloud economics. Of course, this option, the term option has been, let's say, borrowed from the economics discipline, and because the cloud is a business model, so a huge economics is involved in the cloud. So let us see why economics is so important to the cloud. So now you see that economics is important, economy is important because cloud is a business model. A good number of service providers are available as of date in this particular area of the cloud computing, and they are charging the money also from the users, from the organizations that are availing the cloud services, right? So now as they are charging the money, economics is important, right? So you see that, and as the economy is important, the auction plays an important role in the cloud resources. Similarly, you can just visualize other disciplines also. So where the economy is involved, probably you have the possibility of applying the auction mechanism. Of course, for the cloud economics, market participants are the cloud providers and the cloud users. But for other disciplines, you may have the providers and the users. Providers which are providing the services, which are providing the services in forms of hardware, software, applications, whatever services they are providing. So market participants are the cloud providers and the cloud users. Cloud users are those users that are accessing the cloud services. The objectives of the cloud provider is to provide the resources. Obviously, they are keeping their resources, they are maintaining the data center. Then their objective is to provide the resources to maximize the revenue also. Because as I told you, it is a business model. It is not for charity. The cloud service providers are not for the charity. They are for earning the money. And when they are earning the money, obviously their aim is to maximize the revenue. So the objective of the cloud provider is to maximize the revenue and of course to remain in the business as well. They don't want that they should be out of business. They should not be out of business. They wish to remain in the business. And for being in business, they do offer different types of services in different pricing schemes, in different pricing mechanisms. Probably you might have experienced this, which happens with the many of these online service players, online marketing also. They do offer different type of mechanism so that a user is lucrated to go into their service models and can avail their services. So they want to remain in the business, like this online business platform, the Flipkart, the Amazon, and many more service providers that are there. They are forced to remain in the business. They plan, their team plan that what kind of a resource, what kind of offers they can make to the users, right? So these are some of the objectives of the cloud providers also. The objective of cloud user is to get the resources at the minimum cost. Obviously, this is one of the major objectives, that they wish to avail the cloud resources at the minimum cost. So they want that they can use the resources, but they have to pay minimum. And that is why they look at the different cloud service provider also while availing the services, which are offering the same services at the minimum cost, or which maybe they can compromise also. Okay, it is taking a bit more time, but offering the services in lesser pricing. So the objective of obviously the user is to get the resources at the minimum cost, and of course to maximize their satisfaction level also. They should be happy also with the cloud services that they are getting. So thus, while designing the pricing models, the objective is to design an effective and efficient option-based resource pricing. So this is what the objective while developing the cloud resource pricing model using option mechanism. Right. for provider revenue maximization and utilization of resources, and for users the best pricing and the satisfaction. So these two, as I told you, these two are the objective. Sometimes these are conflicting objectives also, like revenue maximization while maximizing the revenue, how the best pricing can be given. These two are the conflicting objectives. So obviously the resource management has to be done, or the goal for the resource provisioning is to be designed in such a way, so that these conflicting objectives are also satisfied. Obviously, the motivation for this resource provisioning and pricing comes from the dynamic pricing. Dynamic pricing means you can offer the pricing which will vary dynamically. So at a moment of time, the pricing is X. At another moment of the time, pricing may be X plus 1 or maybe X minus 1, something like that. So dynamic pricing means the prices are varying. So while we proceed, you will notice that many service providers are actually offering the dynamic pricing. Then another issue is the utilization of the spare resources. Sometimes you offer all the resources, but there are some resources which have been spared, which are less in numbers, which are less in quantity, which probably a big organization cannot avail. So how to how to utilize these resources are another issue with the resource provisioning. Resource provisioning in competitive and strategic cloud market. We say strategic and competitive, these two are the adjectives which we have associated with the cloud market, because a good number of cloud service providers are available. And they are all planning to offer their resources in the best manner, in the best way. So then this cloud market is very strategic market and very competitive also. Competitive because huge number of service providers are available as of date. And of course, one of the issues is the truthful revelation also. So one should not lie also while offering the resources, and one should not lie also while availing the resources also. So there should be a truthful revelation in the cloud market, and this plays a very important role by designing the resource provisioning model using the offering mechanism. So truthful revelation, truthful says that one has to reveal the truth. Does not say I can offer you anything. I can offer you a huge amount of resources in least amount of time. So these kind of revelation which one cannot fulfill. I mean, a cloud service provider offers something which cannot be fulfilled by it, should not be there while developing the resource provisioning mechanism. So thus one has to look into the truthful revelation also in the cloud market. And then of course the healthy competition in cloud market. So healthy competition, we say that at the end of the day there should not be something that big cloud service providers remain in the cloud market and the smaller service providers they vanish because of the monopoly of the big cloud players. It should not be there. So there should be a healthy competition in the cloud market. Right? This is what the objective of the cloud market is. And of course, spot pricing, which is related with the dynamic pricing, plays a very important role in the cloud ecosystem. Spot pricing is something like you might have seen spot counseling while making the admission in this through JEE or whatever mechanism. Spot counseling means you come at the spot and avail your admission. Similarly, spot pricing means you come and see what are the resources. You immediately, I say that you get the resources in this much least pricing that I am offering. If you wish to avail, you avail it on the spot, something like that. So spot pricing also has a role in the cloud ecosystem. Now, if you look at this particular figure, pricing models have been divided into two. One is the static pricing, another is the dynamic pricing. Static pricing further can be divided into two. Static means the pricing will be fixed for a certain period of time. Dynamic pricing is the pricing will vary. Pricing will vary very quickly. So it's a very dynamic. The pricing is very dynamic. Then comes the static pricing, which has been divided again into two. Reservation-based pricing. That is, you reserve the resources for a longer period of time, maybe for 1 year, maybe for 2 years, maybe for 6 months and so. So you reserve the cloud resources for a longer period of time. Is the reservation-based pricing. Then we have the on-demand pricing. Now the prices will be decided on demand. As in when you require the resources, you put your request, and the pricing will be decided depending upon the prices at that particular time, at that particular moment of time, what are the pricing, what is the pricing of the cloud resources will be decided upon that. So that is known as the on-demand pricing. The dynamic pricing, which we just mentioned as the spot pricing is actually the dynamic pricing. As you told that the prices will be decided on spot. On spot we decide depending upon the market strategy that okay, I can offer you the resources in this particular pricing. You can avail the resources or you can let's say skip the resources. So this kind of a pricing, spot pricing, is known as the dynamic pricing. Now introducing you the auction mechanism. So far we introduced just a general part of the cloud related disciplines and why economy is important. Now I'll be introducing you the auction. Do you need a pause or should I continue?
Please continue, sir.
Hello?
Sir, please continue, sir. No.
Okay, okay.
This is a very informative session you are going on, sir. Please continue, sir.
Okay. Okay. So let us see now what an option mechanism is. In general, what an option is. Then probably I come to the cloud option. How the option has been applied for the cloud resources. That will be the third part most probably. Let us see the part two, which is introducing you the option. Now what is an option? Option is a market mechanism with a set of rules. So you define the set of rules a priori. It's a market mechanism because as I told you, it has been borrowed from the economics discipline. So it's a market mechanism with a set of rules determining the prices and resource allocations on the basis of bids submitted from the participants. So the participants in the cloud market, or in any market that are applying the auction mechanism submit the bids, and depending upon the bids and the auction rules, the prices are determined and the resources are allocated. Now these resources can be any resources, not necessarily the cloud resources. Okay, so one can look into, again I say that one can look into the resources that they are managing, right? And then can apply the auction in their particular area. Okay, and of course the auction says that depending upon all these situations, the prices are to be determined. Aim is to optimize the payoff of the participants. When I say the participants, both the participants are included here. The user as well as the service provider. The customer as well as the service provider. Right? And the aim is to optimize the payoff of both the participants. Both are interested in their benefits. So the objective is obviously while making an auction mechanism, the objective is to optimize the payoff of the participants. Winners praise their winning abilities. Winners means ultimately one has to win, right? While availing the resources, while offering the resources of many service providers, one will be able to offer the resources. So he wins, one wins. So winners praise their winning ability and users blame other bidders, not the auctioneer. So now there is a third entity known as the auctioneer. Right? Auctioneer is the kind of a person you can say, or you can say a kind of a mechanism which assists in the auction process, right? Which is used while for executing the algorithm, for executing the manner in which the auction is being performed. So obviously the winners praise their winning ability and users blame other bidders. Other bidders means other service providers. If it is a part of the service providers, not the auctioneer for the loss. The sponsored search auction allocation of limited number of sponsored slots are also there. Obviously, this is something which is related with a particular auction that probably will come to you. Now, as far as the type of auction is concerned, basically there are three types of auction. One is known as the forward auction, another is known as the reverse auction, and the third one is the double auction. All these three mechanisms have been applied in the cloud resource auctioning. Forward auction is from the user's point of view. So let's say if there are few service providers or one service provider, I can say, and they have limited number of resources, but there are good number of users, a huge number of users to avail the resources. Now the auction will be done from the user side, right? That okay, I am interested in availing the resources. Another will say I am interested in availing the resources. This way, n number of users may submit their bid to avail the particular type of resources. And then out of n, the resources will be allocated to one or two or maybe one. Then probably the auction mechanism decides that whom to the resources will be allocated. This is known as the forward auction. Reverse auction is from the other side. That is why it is known as the reverse auction. Reverse auction is from the provider side. That is, a good number of service providers are there. And when a user submits the bid that I want to avail this particular resources, then out of n number of service providers, one will be able to win that particular auction. Winning means one will be able to provide the services to the particular user which are looking for the resources. So now the auction is from the other side, and that is why it is known as the reverse auction. The double auction kind of it is a kind of a auction which is performed from both the sides. That is from the user side, from the service provider side as well. So you see that is why it is known as the double auction. So auctioning is done from both. So users also submit the bids and the service providers also submit the bids. And then the auction mechanism or the auctioneer decides that which service provider will give the service to which user. Right? So this is the kind of a mechanism which is known as the double auction mechanism. Now you see, if you include what are the entities in the auction, now there are sellers, there are buyers, which already I have discussed. Now there is a third entity also in the auction, which is known as the auctioneer. So auctioneer is an entity which assists in the auction mechanism, which of course execute the auction algorithm for assisting the sellers and the buyers. Right? Steps in the auction includes the bid collection and validation. So obviously the bids are being submitted from the users as well as from the service provider. So bids are collected and validated, where it is a valid bid or invalid bid, depending upon that the validation is done for the bids. Okay, so this is the first step in the auction. The second step in the auction is the declaring that the auction has been done. So once a time has been given, okay, you can apply for this particular one, the auction is declared to be closed. Thereafter, valuation and the bid ranking is done. Valuation means now evaluating the bid. Bid is valid, but now it has to be evaluated. It has to be evaluated depending upon the pricing, depending upon the resources, depending upon the configuration of the resources that one is offered. Accordingly, the bid is ranked. Number one, number two, number three. The technical bid as well as the financial bid. They are ranked accordingly. And thereafter, the resource ranking is also done. Depending upon the bid, thereafter, the resource ranking is also done. Okay, this is the highest number, highest ranked resource. This is the second ranked resource and so on. And then thereafter comes the winner determination. That is, the winner is determined. Depending upon the type of auction, the winner is determined. Who will win the auction? And thereafter, the payment mechanism is involved. The payment is done. Payment is performed. Payment mechanism is performed. Okay. So this is some of the steps in the auction which is performed. These are the auction steps, and which is performed irrespective to the kind of auction. That is, whether it is a forward auction, or it is a reverse auction, or it is a double auction. These are the steps which is performed in the auction mechanism. Okay. Now, auction has been categorized also on various entities, depending upon various properties. The auctions have been categorized. On the basis of the role of participants, we do have divided the forward auction, reverse auction, and double auction, which we just discussed. Role of participants, I already mentioned, it is from the user side, forward auction, it is from the service provider side, it is reverse auction, it is from both the sides, it is a double auction. Then on the basis of bidding side also, it can be one side auction or double side auction. Like the forward auction and reverse auction is one side auction. The double auction is a double sided auction. On the basis of pricing mechanism also, the first pricing and the second pricing. Probably many of us are very much aware of the first pricing. That is, whosoever gives the lowest, the order is given to that particular service provider, which is known as the first pricing. Sometimes second pricing is also performed. Do not give it to the first pricing, because maybe the first pricing is in, let's say, has been given, and for the truthful evaluation, sometimes we give it to the second pricing mechanism, second pricing bidders also. So then, on the basis of the pricing mechanism, auction is categorized. on the basis of resources or categorization of auction items, whether it is a single unit, single item, or same item has multiple unit, or maybe multiple items are there, but each items are having the single unit, and then multi-unit, multi-item. On the basis of bid composition, uni attribute, that is the bid is composed of the one attribute, or there are multiple attributes of the bids that have been taken into consideration. So these are some of the types of the auction which is performed. If you look at some of the properties of the auction, these are in general properties of the auction. Efficiency deals with there is no loss of social welfare. Efficiency says that everyone has been satisfied. Incentive compatibility, it encourages the truthful bidding. We call this particular term incentives are being given. Incentives are being given to the service provider or to the user so that one reveals the truth. So this encourages the truthful bidding, and this particular term is known as the incentive compatibility. We just have seen, we just have discussed about the L2, the order is being given or the service provider which wins the auction is L2, the level 2, because it is to encourage the truthful bidding, and this is known as the incentive comparison. This is not the just one mechanism, many mechanisms are involved in offering the incentive comparison. Then bidder's optimality is the property which determines the best possible price from both the sides. Individual rationality is the property which says that there is no harm to participate. I mean, the service providers, they should not discourage the participation. This particular property is known as the integration. And budget balance is something which says that whatever you transfer the money, exactly the same amount reaches to the service provider. Then we say that the option is budget balance. And of course, you encourage the fairness or egalitarian social welfare, which is known as the egalitarian social welfare, which reduces the difference among the people. There is nothing like rich middle and the poor middle, which we have mentioned previously also. So that the monopoly of some bidders are not there, are monopoly of some service providers do not remain in the market. Rather, the market is fully happy with the rich middle as well as the poor. Right, so that particular property is known as the egalitarian social. Now I come to the third part of the auction-based resource provisioning. But here I'd like to take a pause in mind. Okay, so is it okay?
Yes, sir. Yes, sir.
Okay, so I'll be back just in 2-3 minutes and not more than that. Okay?
No problem, sir. No problem.
तो हम पूछते हैं ऑप्शन कंप्यूटर के बारे में ये हाँ
Meanwhile, it is requested to all participants, if you have any doubt, query, and any question related to this topic and this session, you please ask with our resource person. You can ask your question or your query by submitting your question in chat box. At the end of this session, as we already informed you, already discussed, we will open the feedback session. In that session, we will surely allow you on the basis of your question to interact with our resource person of this session. So if you have any doubt, any query, any question, you can submit your question on chat box only. And it is requested to all participants to please mute your video as well as audio mic while session is going on. Some participants open their video camera, so it is something disturbing in between. So please, it is requested to all participants to please mute camera and mic both during the session. We will discuss in open session at the end of the session when resource person completing their presentation or discussion. Participants, you may ask question in chat box. As this session is related to cloud computing, and as we know, it is one of the major data repository where we store our data and process our information on the basis of the given context in the given context in given as per the requirement. So this is one of the very useful topic related to data management, where the auctions related data and cloud related data we process in with huge amount of in very good manner. We can process our data.
Hello.
Yes, sir. Please, sir. Please.
Yeah, I'm back now. I'm sorry that
No,
I
no
had to go.
problem. No problem, sir. Please, sir.
That was an important call, so I had to go.
No
So,
problem.
now coming to this part 3.
Yes, sir.
The auction-based resource provisioning in cloud computing, and where we do have applied all these type of options for the provisioning of the cloud resources. Let us see how these have been applied. So the first one which we, let us first discuss something. Why auction in cloud computing? I already told you many a times that's a business model. The resources are to be utilized. The pricing are very dynamic because good number of service providers are joining the cloud market. And of course, to prevent the market manipulation also, so that the monopoly of some of the market, let's say, service providers are not there in the cloud market, the auction in cloud is very important. And it has been well taken, and many of the good service providers like the Amazon, like the Microsoft, they are applying the auction mechanism while offering the cloud resources, their cloud resources. So auction mechanism is very well taken by the cloud service provider. Right? The actual implementation of the cloud, the auction in cloud by the Amazon, which started applying giving the spot instances, as we discussed some times back, the spot pricing, spot instances are created. Instances of the cloud resources are created, and they are offered as the spot instances by the Amazon. Even the Virtuous team also acquired this Spot Cloud. They called it as Spot Cloud in offering the cloud. And of course, the model-driven approach for design and execution of multiple clouds, they also adopted the Spot option. We'll be discussing therefore the first spot pricing in the cloud computing. What exactly is the spot pricing in the cloud computing? Let us see what the spot pricing is. Now, if you look at this particular picture, you will be able to exactly guess what spot pricing is. So you see that the number of users are there, and they are ready to access these cloud resources. So let's say these are the cloud resources. These you may just assume that the size of this rectangular box is the size of the cloud resources, the size of the virtual machines, in terms of the hardware, software, in terms of the storage, whatever it is. Think you can assume, you can feel it. Now you see that the users says that they want certain resources, and the cloud provider collects these bits from for the spot instances and the asking. That is, user says that we want these resources, some of the resources which are available as the spot instances in this much of the pricing. Right? In this much of the pricing, we wish to avail the resources. So this is a request which is being sent from the user's side to the cloud service provider. I mean, to the, you can say, to the auctioneer also. The bids are submitted to the auctioneer. Auctioneer here, you can just assume that the spot pricing mechanism is the auctioneer, which decides that how the bids will be given, how the resources will be given to the user. The provider checks if asking price. Asking price is something in which the user is asking that you please give me the spot instances in this much of the pricing. I have this much money available. If you can provide me, it will be good or something. So now the provider checks if asking price is more than the spot price, VMs or the virtual machines are there. Right. So if asking price is more than the spot price, so they already have decided the spot prices, and I already told you the spot prices vary from one time to another. That is depending upon the different time instances, the spot prices vary. So let's say when a user asks the asking price at a particular moment of time, and at that particular moment of the time, asking price is more than the spot price, then the virtual machines are available. Then it keeps on checking spot prices, and whenever it goes above the asking price, so now you see that it continuously monitors. It continuously monitors that the spot prices are within the asking price, then the resources are given. But when the spot prices increases, that it goes above the asking price, then the virtual machines are abruptly terminated from the user. You can say this is one of the drawback of the spot pricing also. That is, the user is availing the resources, but abruptly it may be terminated because the spot prices has gone above the asking price, which has been given by the user. Now, whenever a spot price goes below the asking price, the spot instances are again granted. So now let's say the spot prices, as I told you, varies from time to time. If it goes below the asking price, then the spot instances again are granted. Prices of the spot instances are changed, not the asking. Asking price remains same because the user they cannot give you the money more than this. Then the asking price remains same, but the spot price is varying. So now if you look at this particular spot pricing mechanism, you can just guess that what kind of applications can be executed availing the spot instance. Now, not every type of applications can be executed by the spot instances. By the spot instances because obviously some sort of a time will be given so that the user can decide what he has to do. But more terminated abruptly when the spot prices goes up, and that is why one has to find the suitable applications that can be executed for this problem. Let us see at this particular picture. The red one is the asking price, and you see that the asking price is fixed throughout the time. So at the x-axis you have the time, at the y-axis you have the pricing. So let's say the asking price from the users is fixed, from the user are fixed, and which remains constant throughout. So this is the user bit, the red one is the user bit, and the blue one is the spot prices, which is being offered from the Amazon spot instances. This is a particular example of the Amazon EC2 mechanism, the Elastic Cloud. Now you see that in Elastic Cloud. So if you look at this particular graph, you will find that the asking price at this particular time is more than the spot price instances. So the spot instances will be given to the user and the user will avail the spot instances. So from A to B, though the spot instances are, spot price instances to spot prices, pricing are varying, but it is well within the asking price. So the resources will be available with the user. At point B, the spot prices goes up. So now at this particular point, the spot instances will be snatched. As I told you, it will be abruptly terminated, and that is why I am using the word snatched. The spot instances will be snatched from the user at time B because the spot prices goes up. And it remains here up to time C, and at time C again the spot prices goes down. So again at C the spot prices, the spot instances will be given to the user, which will avail the spot instances as long as the asking price is above the spot. So this is the exact mechanism which has been adopted by the Amazon EC2 Cloud for the spot instances. So as I told you that the spot pricing mechanism may not suit to all applications, but it has been found to suit in many applications. And you see that for scientific computing also genome analysis, because sometimes you can terminate some of the processes when the spot prices goes up. So that is why some of the applications which has been found, and a good number of applications have been found to be using the Amazon spot instances, right? So this is one mechanism. Amazon continuously evaluates the remaining instances. Why the prices vary? Because it sees that what are the remaining resources, what are the remaining pool of the resources available with the Amazon that can be offered as the spot, right? So that is why the pricing varies. So this is the exactly which has been adopted by the Amazon. So Amazon continuously evaluates the remaining instances in the spot pool and update the spot price continuously based on supply and demand, right? Based on the supply and demand, because if the demand is more, then probably the Amazon spot instances may be priced high. If the demand grows and you have more resources, more available resources, no one is availing those resources, then of course the spot prices may go down. So it's totally depends upon the supply and demand of the spot instances, right? So as and when it increases, it varies, the spot prices also varies. I already explained you the mechanism. User places the request. If the bid exceeds the spot price, user gets the instance. If it increases the spot price, immediately it is terminated. Here it is written Amazon abruptly terminates the instance. Right. So this is the mechanism which has been adopted by the Amazon spot instances. These are some of these spot instances, actually, which is being offered by the Amazon EC2 Cloud. If you look at these the API names, you'll find that small, memory large, and something like this. What is the meaning? That also has been written, right? So these are the EC2 spot instances, which is being provided by the Amazon. Of course, I already detailed you on this. So, cloud spot instances, spot pricing, and the spot kind of auction has been introduced. Of course, we do publish one paper also on this in Journal of Network and System Management, a survey on spot pricing in cloud computing. So it includes the complete survey on the spot pricing. Now, coming to the forward auction-based cloud resource provisioning. Now, here we do have applied the forward option. As again to explain you, the forward option is from the user side, right? The user, there are a good number of users, and there is one service provider which offers the cloud resources. Forward option, also known as sell-side option, has multiple buyers and single seller. As I again explained you repeatedly that there are multiple buyers, multiple users, but a single service provider, single seller in the auction market. In cloud computing, Amazon sells its unutilized capacity with forward auction. So not only the spot price instances, rather using the forward option, also the Amazon sells its utility. For the cloud buyer, the buyer compete by bidding their valuation for the required quantity of resources. So whatever the quantity of resources are required, the buyer puts, and not only one, there are multiple buyers, multiple users. All users in the cloud market compete with each other because, as I told you, the resources are less, users are more, so the users compete with each other to access the limited amount of resources at minimum cost and desired quality of services. For cloud provider in this environment, the provider will provide to maximize their revenue by selling more virtual machines provisioned from their servers at optimal price. Right? I'm coming to this particular figure immediately so that one can understand what exactly is the forward option. So you see that there are number of users. If you look at this particular figure, there are number of users which submits their bids, to the auction. So the cloud provider collects the bids, instance type, that is what kind of resources are required, how many resources are required, the availability zone, the bid value also, that is the pricing also. They can say that, okay, I can maximum offer you this. So maximum kind of a pricing also they can put from our cloud to the auctioneer. Then ultimately the provider decides that okay, this particular resource will go to this particular user. So this is actually the auction mechanism, forward auction mechanism for cloud resources. Obviously, it has been formed in a combinatorial form because not only one property, rather it may avail many property. It may be decided on many, many what we say attributes, like it may be instance type, number of instances, availability zone, bid value. Bid value actually is the prices that the users may offer. So you see that n number of users are there and they may offer it in a different way. Reported single unit, single item, and combinatorial. There might be single unit, single item, or there may be combinatorial reverse auction also, which has already been reported in the cloud computing discipline. Cloud buyer prepares its call for proposal. As I told you, the cloud provider, it prepares the CFP. That is, it requires this particular resource. It requires the resource. Let me see in what price the resources can be offered by the service provider. Providers then prepare their offers in form of a bid to compete with other providers. A bid is prepared considering a combination of various types of resources required by the customer. So again, it is a combinatorial type of an auctioning in which the combination of various types of resources that are required by the user or by the customer is submitted as the call for proposal. Accordingly, the bid is prepared. Usually, the providers are reluctant to reveal the true value of their resources because there are a good competition now among the service providers. So they do not reveal their true value. They do not reveal the true value of their resources. And sometimes they may lie also. And that is what the auction mechanism has to provide some sort of incentive that we call as the incentive compatibility, so that the truthful revelation requirement to the auctioneer in terms of the call for proposal. Now, the proposal is communicated. So there are n number of service providers which gets the call for proposal. That is, the user requires this much. How you can provide this and in how much pricing you can, what type of services you can provide. User is looking X, but you can provide X plus one also. That is, there is no harm in providing X plus one. Right. So this way, the number of service providers, they submit their bids. Now the cloud auctioneer decides that which provider wins the auction, and accordingly, the user avails the services of that particular service provider, and the payment is made from the user to the service provider. Okay, so this is the mechanism of the reverse auction. This particular mechanism is known as the reverse auction mechanism. If you look at this sequence diagram of the reverse auction mechanism of the cloud market, you'll find that the cloud customer, here you have the cloud customer, here you have the cloud. And in between you have the cloud auctioneer. The cloud customer submits the requirement and the auction is started. So it is a call for proposal. The auction starts here itself. Right? The auction starts here. That Thereafter, the requirement is published. That is, what is expected by the cloud customer is published among the number of providers. So the third sequence or the third step in the reverse auction is publishing the requirement. Then, depending upon the requirement, n number of service providers, they submit their bids. They submit their bids to the cloud auctioneer. The bid is, of course, acknowledged by the cloud auctioneer, and the auction is declared to be closed. So obviously, the bid submission is to be done by the stipulated date and time. Thereafter, the auction is declared to be closed, and the auction is closed, and which is informed to all the service providers that hereafter you do not service. Thereafter, the screening process is done by the cloud auctioneer in order to determine the result of the auction. Thereafter, the result of the allocation is communicated to the cloud provider as well as the cloud customer. The cloud customer is indicated that, okay, this service provider has won the auction and we will provide you the service. Obviously, the cloud provider also is communicated that, okay, you are able to win the auction or you are not able to win the auction, depending upon the result of the allocation. Thereafter, the resources are allocated to the cloud customer. Cloud customer executes the task, get their result, and makes the payment mechanism, and the auction is ended here. So this is exactly the sequence diagram of the reverse auction mechanism, specifically in the cloud computing area. These are some of the results which we are able to offer, which we are able to get. How the procurement cost decreases and how the resource procurement cost decreases depending upon the quality, number of providers and the number of the quantity of virtual machines, right? So we do have developed some of the models known as the TFM-CRA. If you are interested, if you are more interested, I can forward you the paper also, or you can look into the papers, which is truthful revelation of the multiple clouds in the combinatorial reverse auction, and another is the truthful combinatorial reverse auction. These two models we do have developed, and in which we found that the model is reasonably able to decrease the resource procurement cost. Not much result, I am not able to put the much result here, but this is the paper which has been published, and all these results are available there. Published in the IEEE Transaction on Services Computing as a truthful and fair multi-attribute combinatorial reverse auction for resource procurement in cloud computing. And if you are interested, I can forward you the paper, or even it is available on the net, you can avail this particular paper and can you just browse into that how the reverse auction has been applied. Now, contribution goes to applying even the double auction in the cloud resource provisioning, and how the double auction has been applied. Let us look into this. As I told you, the double auction is from both the sides. So there are a good number of cloud providers that are ready to offer their resources to be used by the good number of cloud users to perform their tasks. So now a number of cloud users and number of service providers, and then some kind of a matching is done in the double auction mechanism. Which cloud provider will be giving the service to which cloud user? Similarly, which cloud users will be able to avail which cloud service providers is decided by the auctioneer. Now it creates a good competition at both the sides in the cloud market, because now you have good number of users, you have good number of service providers. So usually the double auction mechanism is most preferred mechanism in the cloud market, because it satisfies the good number of users, the requirement of the good number of users and the good number of service providers. So it creates a good competition at both the sides. Users compete with each other in obtaining the limited amount of resources, and providers compete with each other to offer their services in order to increase their revenue. This type of market environment can be modeled using double auction, and double auction can be used to design unbiased optimal market strategy in the cloud market. If you look at this particular picture, you'll be able to exactly point out what the double auction mechanism is. Now, there are n number of users and there are n number of service providers. All the users submit their bid. These bids may be, they submit the call for proposals, which may be entirely different. Each may be entirely different. Similarly, the providers also submit the bid, maybe for all the users, maybe for some of the users, the bids are being submitted by the service providers. then the auctioneer decides that which service provider will be able to win the auction for which user, right? So accordingly, it is decided by the auctioneer. Just skipping all these things and coming to this a fair multi-attribute combinatorial. This particular model was developed by some of my research students, by our research group. They use the multi-attribute, they use the combinatorial, and they use the double auctioning. So all these they have applied in developing the multi-attribute combinatorial double auction model for resource allocation in cloud computing. Why multi-attribute? Because the quality of service is an important factor, and when we say quality of service, there are multiple metrics which is involved in the cloud computing to just judge the quality of service. And of course, the reputation of provider in the market cannot be ignored. So that is why it has to be multi-attribute. Why combinatorial? Because offering of resources is in form of the virtual machines, and customers are able to express their required resources, which are dependent and complementary. And of course, why double? Because number of multiple provider and customers are there, which I just explained you. More efficient than single side auction. That is more efficient. Double side auction is more beneficial, more efficient than forward auction and reverse auction. And of course, it prevents the provider's monopoly also. So this was the reason that this particular model was developed. Some of the challenges that we are able to reach out by developing this particular model. Many of the things have been considered. If one is interested, again, one can look into the papers that we do have published. If you look at this particular sequence diagram, you'll be able to differentiate the double auction than the reverse auction, which we just discussed. Here you see that the auction is started. Now this cloud provider this is the provider, this is the broker, this is the user, not the broker. This is the user which submits the bids. So both are submitting the bids, which is being acknowledged by the auctioneer, and auction is declared to be the closed auction. Thereafter, after closing the auction, the result of the bids are evaluated, and the result of the allocation is communicated to the cloud provider as well as to the cloud users. Resources are allocated from the provider to the user, which executes the task, which gets the result, and of course it reports the quality of service also. So after availing the resources, it reports what kind of services it could avail from the cloud service provider. Because the final price, the determination of the final pricing will be determined upon the feedback from the cloud user to the cloud service provider, to the cloud auctioneer. Because maybe the cloud service providers promise to offer you good quality of service but could not provide, then obviously the final prices may be decreased for the user, and accordingly the calculation of the final pricing is done. As you see that here we have written calc final price. It is actually the calculation of the final pricing depending upon the feedback of the user. The final price is determined, which is communicated to both the provider and the broker, provider and the user, and eventually the payment is made. So this is the exact diagram, sequence diagram for the double auction mechanism in the cloud computing area. So this is how we do have applied the double auction using multiple attributes, making it a combinatorial, adding many of the properties of the auction in the cloud computing area. And this way we are able to apply the auction mechanism in the cloud computing area. And concluding this particular discussion, our discussion, that cloud has become a marketplace. Business of computing resources is done. Cloud resources are offered in form of a service on a payment basis, becoming very competitive market. Day by day, the number of providers, service providers are growing in the cloud market, which makes it more competitive. Recently, a sharp increase in number of cloud service provider and number of customers have been out there. You see that a lot number of customers are also now moving. Customer in terms of the big organizations are moving for availing the cloud service providers, for availing the cloud services. So new challenges are emerging, new issues are coming in the provisioning. Now, as the fog computing, which we just discussed some times back, the fog computing area of the fog computing, this particular paradigm has also been introduced. Now fog cloud together, that is the fog integrated cloud has come. So how the resource provisioning will be done considering the fog integrated cloud gives more challenges, produces more issues, and gives the opportunity to do research in this particular area of the fog integrated cloud, and obviously to apply the this auction mechanism in the cloud computing. Of course, many challenges have been pointed out, many challenges we do have discussed. Many challenges are emerging with the introduction of newer and newer types of user, newer and newer types of services, newer and newer paradigms that are emerging, right? The newer and newer challenges are coming. And that is why we do have more and more opportunity to do the research in this particular area of applying the auction mechanism in the cloud computing. Now, if you are more interested in knowing about the auction, specifically the auction in cloud computing, then we do have produced a book also. So recently it was published by the Springer in form of the auction-based resource provisioning in cloud computing, which has been published as the Springer brief in cloud computing, with the help of some of my students. These three are my students and all are faculty in the good places. So this particular book also can be looked into if one is interested in applying the auction. This is specifically with the cloud computing, but then the same can be used in other areas also. Some of our publications, these are some limited publications which you are able to make from these research. This number has grown further. The talk includes these few publications only, and that is why I have mentioned these few publications related to this particular talk. Some other applications, if you are interested in where the auction has been applied in some other applications other than cloud computing, then probably you can look into this particular paper of auction mechanism for virtualization in 5G cellular network. So you see that the auction has been applied for the 5G cellular network, which has been published in IEEE Communication Surveys and Tutorials. And then in the network function virtualization SDN market, software defined network market also, the double auction has been applied. So a double auction approach for resource allocation in NFV market, which has been published in IEEE Transaction on Network and Service Management. One can look into these also and can decide on that how the auction can be applied in their particular area. So putting all together, our research addressed several interesting problems on a research area, resource provisioning and pricing, and tried for novel solutions to its economic aspect, which makes our research clearly distinguishable in the literature that lies in the intersection of computer science and economics. So these two disciplines works together in developing some beneficial model by applying the auction mechanism for the cloud resources. And that's all from my side. Thank you very much. Thanks a lot. Now, if you have some questions, you can put into. Hopefully, I'll be able to address those.
Yes, sir. Very much, sir. Very much. Thank you, sir. Thank you for sharing your valuable delivery related to this cloud computing. And this is open session now. You, dear participant, if you have any question, you can ask directly to the Professor Vidyarthi sir. His knowledge in this area is very much, we can learn, we can surely benefited by the talk given by the Professor Vidyarthi sir. Sir, already one question already given in chat box that how cloud computing is used in machine learning.
Now you see that machine learning is usually, now even we are using the machine learning in cloud.
Yes.
I should have given another talk also on machine learning also, how to apply the machine learning in cloud computing.
Yes.
So now in order to determine in order to make some sort of a prediction that what kind of a request may come to the cloud, so that we are ready with the provisioning, considering the fog as well as the cloud. So these kind of a research we are doing, and we are heavily applying the machine learning now. Nowadays, many of my research students are working on applying the machine learning. So you have plenty of possibility of applying the machine learning in determining that what kind of a request may come, what kind of a users may join the cloud bandwagon, what kind of a organization may join the cloud, and how the resources can be allocated considering or judging are making the prediction out of the request which is being generated. So that way, the machine learning is also being applied in the cloud computing, in the fog integrated cloud, in the fog computing area, in the mobile computing area. So if one is interested, one can look into how to apply the machine learning. Of course, as I told you, our group is also working on applying the machine learning. We are able to produce some good research papers out of applying the machine learning in the cloud computing area. Okay.
Yes.
Sir, good afternoon, sir.
Good afternoon,
Sir,
please.
security issue can be disturb the integrity of the organization.
Security is a different aspect, altogether a different aspect, and that is why security has to be looked into. Security is being looked after, but then further how the security mechanism can be improved, or how the privacy and security can be ensured, this is altogether a different aspect. And again, to tell you that we have started applying even the blockchain mechanism also in cloud, blockchain in fog integrated cloud, and blockchain in many other disciplines of related with the cloud and fog computing. Security is very important aspect. One can look into what are the security. As I told you, it is one of the major challenge in the fog and cloud computing. So security is of course a challenge, of course a field, of course an issue, which has to be looked into, which can be looked into.
Okay, sir. Okay, sir. Okay, sir. Thank you, sir.
Anyone?
Any more?
Satish sir, you have one question you sent to me.
Yeah, please.
Yes, sir.
Hello.
Yes.
Is there any more questions?
No, sir. Thank you, sir. No.
Okay. If there is no question, then thanks from my side. You listened me almost
No.
2 hours.
Yes, sir.
And you had the hearing patience to listen me
Yes, sir.
altogether.
Yes,
so
sir.
I'm very much thankful to you also. Thank you very much. Thanks a lot.
Thank you, sir.
Thank you, Professor Tripathi. You convey my thanks to Professor Tripathi.
Sure, sir.
Dr.
Sure, sir.
Thakur.
Yes,
Thanks a
sir.
lot.
Sure.
Thank you very much.
Thank you, sir.
Listening,
Sir.
listening, and grateful to you.
Okay, sir. You are also here. Okay. Thanks a lot, sir.
Okay.
Thank you
Special
very much.
thanks from my side also.
Thank you. Thank you, sir. Okay, thanks a lot.
Thank you, sir, for joining us. Thank you. Dear participants, all are requested to please fill this attendance through using Google links submitted in your chat box, as well as the feedback form of the session, which is mandatory for all participants to fill. Please fill for this session, and this is the session 2 we are completing, and the third session will start at 3:30 after lunch. There is one hour break for lunch session, and then after lunch session we will start at 3:30 with the next session, which will be delivered by Professor MC Trivedi sir from NIT Tripura. So one of the quite interesting and useful session for us. So please fill this attendance as well as the feedback form of this session. Thank you all for joining us. Thank you. Please we will be sharp at 3:30. We will join again for the session 3 of day 1. Thank you. Thank you all. जी सर, हाँ उनका एक मैसेज आया था तो मैंने कंफर्म कर दिया था सर उनको. व्हाट्सएप मैसेज आया था कि मैसेज एट 3:30 क्वेश्चन लगा के दिया था, तो उन्होंने हमने यस कर दिया था, यस सर।
इतना बड़ा ब्लैक है
अभी वाले सेशन पूछ रहे थे।
हाँ। ये टाइम लगेगा, मतलब अभी आधा घंटा और ये हो जाएगा पहले।
रिकॉर्ड नहीं हो रहा